Right. So, welcome to week 11. We are toward the second half of the Python 100 series. Hope everything's doing well. And yeah, so today we're going to use a used card dataset from Kaggle. So I'm using Colab Notebook, but this dataset was originally from Kaggle, so you should be able to also use it directly on the Kaggle Notebook website. So this is just some script to download the data sets, and you can see, okay, it has manufacturer, it has model, it has engine size, fuel type, something, something, something. Some of them are in different like data type. I am not converting any of them as of now, but we'll see. Maybe we will need to convert them slightly later. So this is just a quick overview of the data sets. We have about 50, hold on, yes, 50,000 rows in this data set. This is a medium-sized data set with a couple different rows that you're going to see commonly when you're like buying a car, maybe. You got price, you got the manufacturer, you got the year, and so on and so forth. Common used car data set. Okay, so first thing today, we're going to do a little bit more like deep dive into the basics of Matplotlib. It is one of the most, if not the most common plotting library in Python. I think it got its name because it is basically trying to replicate a MATLAB plotting experience in Python. If you don't know what is MATLAB, it was one of the like software and other programming language that's commonly used by data visualization and scientists back in the days, but you need to know a different language called MATLAB. Fortunately, we have a Matplotlib that allows us to do most of the similar plotting in Python. Feel free to dive into that. Maybe you will need to use MATLAB sometimes in your life. I don't know. Anyway, so one of the key objects in Matplotlib is this pyplot. So this is basically the plotting object. Think about a class of objects where you have a lot of different attributes inside. So usually we will just, what's I'm doing here, import matplotlib.pyplot.plt. That means we're importing this object, this class, this object into our environment. And inside this object is where you define different types of plots. You have line charts. Default plot is a line chart. The scatter plots, bar chart, histogram, pie charts. You have plenty of more different plots. You can even define your own plots if you want. You can just inherit from pyplot object and kind of play around it, create your own type of plot if you wish. And of course, each of the plot exists for different reasons. So we're going to see some of the methods we're going to do today. And inside each of the plot, you can also adjust the visualization of that, or think about plotting. You can, okay, I want the dots to be red, I want the dots to be blue, and so on and so forth. These are something you can also set up. You can also set, oh, I want to change the font of my title. I want to change the size of the numbers. I want to change the figure size. I want to make it stretch more horizontally. I want to make it stretch more vertically. These are all adjustable with different methods in the plot. And I think I should include a link to their official documentation. But yeah, you should be able to find where is it. Just Google Matplotlib documentation. You'll see a bunch of different options you can do with the plot. So this is for, if you set as, well, these are just some other informations that we might need. Personally, I don't think anyone ever memorized every single commands or plots in this entire library because there are way too many of them. Usually we were just like, okay, I need this plot, how do I use it? The old-fashioned way is to go to the documentation and copy-paste a lot of stuff, and until you remember yourself how to do it. These days, you can ask AI to plot this for you. They're usually pretty good, with a but. sometimes they may plot something you think it's correct, but it's not. We're going to see some example today. And so, well, the thing is, it's very easy to plot things out, but how do we make sure are we making a good plot or not? We have in this session we're going to focus on a couple of things, especially on line plot, bar plot, and histogram. And when do we choose the right plot for each? Well, for a line plot or a line chart, I think the most common usage case is when you have a continuous time series, or like you're plotting, for example, the sales of the car from maybe January, February, something that's sequential. It's a great option for a line plot. Can you plot something that's not sequential and still use a line plot? Yes. It will not trigger a bug. But the point is, then what's the information you're trying to tell from that chart? Usually you see a line, you just try to see a correlation or something. But if you're not trying to illustrate a correlation or a trend, then why are you using a line chart? So most of the time, when you're using a line, you're trying to illustrate a trend of something. As for a bar plot, it's usually for categorical variables that's not associated with each other. So I would say there's the best practice for bar plot versus line plot is that, okay, you can break down the sales. Let's try to, well, we'll have some example later. And histogram. Histogram is a little bit more statistical, but it's basically showing you, okay, how many times this type of data appears so far. So there is, like, in a lot of cases, you can, like, as long as your data is numeric and is in the right data tag, you can plot however you like. But the basic rule is, okay, if your plot looks messy and doesn't tell the information you want to say, you're probably doing something wrong. Either your information is wrong, or your hypothesis, the thing you're trying to say is wrong, or you're doing something wrong in data manipulation. Let's think about one quick example. So one quick look into the data set, I think I have some story to tell about this. So I can see, okay, the higher the mileage, the lower the price. I mean, that usually means the car is older, right? The car is driven a lot more, the car is used a lot more, it's a lot older, so it's a lot cheaper because it's a used car. And the car that's newer, which has like lower mileage, it's going to be more expensive. Of course, it also depends, it's not perfect because it also depends on engine size. If a Porsche is going to be more expensive than a Ford, even if the Porsche is used a lot more than the Porsche, something like that. But in general, I think there is a relationship between like an inverse relationship between mileage and price, which means that the higher the mileage, the lower the price. The lower the mileage, the higher the price, right? This sounds pretty intuitive. And today I'm trying to see if I can observe this pattern, if I can verify my hypothesis with this data set. So to start out, I'm trying to plot, see, okay, what is the distribution of the price? And if you're more well-versed in statistics, you can say, okay, this is apparently not a normal. Well, it could be normalized. You could say it's normalized but truncated, but probably this is something that's skewed. You have something that's very, very expensive, something that a lot of the data is close between 0 to maybe less than 5,000. And you can easily verify this from the price. The highest possible is, okay, 168,000. And the cheapest one is only $76. So I can see some skewness in the data set because, well, my mean is 13,000, close to 14,000, but my median is only 8,000, slightly less than 8,000. I can observe some skewness in this data set. And this is more on the statistical side. It's not about Python, but from this data set, you can see, well, you can try to think about the statistical definition of this and think about, okay, how is this going to influence some of your business decision in future, if that's where you're heading to. Okay, but let's go back to my original hypothesis. I am guessing that there is an inverse relationship between mileage and price, right? So how can I see this? Well, maybe if I plot them, like plot the relationship, how can I see something is a positive relationship? That means one thing is higher, one thing is higher, the other thing is higher. Then I will see a straight line like this, right? Okay, can I verify this? Now, this is what I'm doing here with a scatter plot. Okay, I have price and mileage, and I'm plotting it. Am I making a good plot here? It doesn't seem to show the relationship I want, or it kind of. I mean, you can if you plot the line of best fit, you can see okay, it's still kind of a negative relationship, but it does look messy, right? And am I doing the right thing here? Am I? And I can also plot line charts, but this looks even more messy. It's jumping around all the time. It seems like I'm doing something wrong. So, am I doing the right thing here? Can anyone tell me, is this a good plot? Type +1 if you think this is a totally perfect plot to do. Type -1 if you think there's something wrong. -1. Okay, I see one -1. How about others? Let me. So when I'm plotting this thing, I am plotting two series, right? So, oh, okay. So this is 49,704, something like something. So this series is kind of randomized, and that's it's randomized in price, right? My price is currently not aligned, and so does my mileage, right? What could be the problem? Well, that probably means that that's the reason why my price and mileage are jumping around because they are randomized. So, in order to see the positive correlation, I should try to sort the values, right, by price or by mileage first. So that is something that I'm not doing right. So instead of plotting directly, I should sort my entire data frame by the price, and then I can see the patterns slightly better. It's not perfect still, but okay. Oh, it's not supposed to be plot. It's scatter. It's not that perfect, but now it's looking better. And the thing is, you're not supposed to use a line plot for this thing at all. Because, well, a line plot is supposed to show a time series and chains, but when you have something that's super jumpy, a line plot may not be your best bet, especially when you have things that's going back and forth. So, there is something that we need to, this is something that we will need to be careful. And if you want to see the better pattern, another thing you could do is price sort values. See the of sort values. This one will allow you to see this pattern better, but is it doing the right thing? The answer is no, because you're not sorting it correctly. So let's actually create this df sorted as f.sort, right. So you can see now what I'm doing is, okay, I'm sorting the price from low to high, and then the mileage is sorted accordingly. So this is what we're supposed to do here. And you may say, okay, it still looks messy. So what could we do? Well, one thing you could do is to reduce the number of points you have on the plot and remove the outliers from the plots so that you can see the patterns better. You should see this. Okay. We'll need this again. Or you can twist it around a little bit and you should see the pattern slightly better. But in general, this is the thing we're seeing. If you do this, I don't think you're going, yeah, it's going to be less jumpy with that. I guess it's better to do the line plot based on the price because I'm sorting by the price. Yes. The plot. Now I don't have this jumpy line issue because I finally sorted by the price. It's still not as ideal as I want it to be because, well, I think the alignment is not right. This is maybe useful if I plot it. Let's say I only want to observe the patterns here beyond, let's say, 100,000. So one thing I could do is use this argument we set here to set the range so that we can observe the things more clearly. And I'm not saying the y limit should be, okay, I'm not saying any y limit. Hold on. Now I can see some more patterns. I guess I probably still want to set my y limit. Y limit into, let's say, 0 to now I can see a slightly better plot than before. Okay, I can also change that into a scatter plot. I don't think line plot is the better one for here. Now, this is a more acceptable plot, ultimately. Okay? Sometimes you may want to restrict the range so that you can see the pattern more clearly. Sometimes you may want to set it, let's say I want to set it here. And let's see. I want to adjust the zoom, like the scale of that so that I can see the cluster of data more clearly and so on and so forth. There are infinitely many things you could do to adjust your visualizations so that you can see the patterns slightly better. I think this one showed a pattern a little bit better than the other one. But the point is, there are many different things you can adjust to make a good plot. That's what we're trying to do here. And I would say make sure you sort your data set before you're trying to show a positive or a negative correlation pattern is very crucial. And also, you're not supposed to show like a very complicated pattern with a pie chart. So that is something you might encounter sometime in your life. Okay, I think there is a good correlation, but my plot isn't showing it. Am I doing something wrong? Is my correlation wrong? Or is my plotting wrong. I mean, I could test if the correlation is real by statistical method. But if I am convinced that okay, this by statistics, there is some correlation, but my plot isn't showing that. Well, maybe you should adjust that. And how do you show if there is a trend statistically? It's a different story. You could use something like an OLS estimator. You could use something like machine learning algorithm to see if there is any pattern. It's up to you, but it's beyond the scope of this class. Okay, that being said, let's move on to the first exercise today. So I'm just trying to create a simple pie chart showing the type of vehicles I have based on fuel type. But I'm running into a bug. So this is the final target I want. I want to show, okay, it's a petrol car, it's a diesel car, it's a hybrid car. But hold on, when I plot this, I got a value error. Could not convert string to float. Petrol. So it seems like for everything I want to plot, I need to make sure they're numeric type. So how can I do that? So that's the exercise for today. One, I'll give you a hint. There is a function called value count that will give you something like this. Okay, so how can I make sure I have the right proportion of my fuel type? Petrol is slightly more than half, yes, as indicated by this chart. How can I go from this to this chart? I'll send you guys into breakout room and see if any one of you could come up with the right idea. It seems like I need to convert everything into a numeric type, at least for the data. And there is another thing called a label that's going to basic mode. This is basically this is one way you could do it, but it's not the right way here. So I also need to add a label. So there's two things in this one. I need to convert these things into numeric types and count how many of them are there in my pie chart, and then create a label for that. So how can I do this? Let's see. We're going to create a breakout rooms. I think we only need 2 rooms, I would say. Okay, let's come back to how can we fix this in 5 minutes. Okay, should be able to see the breakout room. Feel free to discuss with your other classmates. And let's see, how can we make sure our pie chart look like this at the end? Okay, welcome back to the main room. Does anyone have any idea how can I fix this and finally get this pie chart? Anyone? Any idea? Feel free to type in the chat or just shout it out. Seems like I need to convert this thing, fuel type, from petrol, diesel, and hybrid into number in some way. Any idea? So let's think about this one. What would happen if I try to call this? This is a number, right? It doesn't have a. Oh, hold on. That's because I said a different thing. Should run it again. I shouldn't run that one. Okay. What would happen if I write this? Run this. I would probably get a really nasty pie chart because I have 50,000 different price, and that means my pie is going to be sliced by 50,000. Okay, it's not showing. I think it's going to take a while to actually show. It's going to slice my pie into 50,000. Okay, let me restrict the range so I can make it. Oh, I'm collapsing my own thing. Okay. This is what happened when I slice it this way. So behind the hood, what pie chart doing is that it's going to sum all the numbers. Here I have 50 numbers and assign a slice of the pie to that number based on how large it is. So in order to create a pie chart like this, I want to make sure, okay, I got these three numbers into as my first argument. Is it value count? Value count dot values. Notice that it's going to give me value count dot values. Remember, this will give me these three count values. And now I still need the fuel type, this three petrol, diesel, and hybrid thing. Line up with that, right? So the easy way to do it is to just get an index out. Hold on. Can fuel type, value counts, the values, something wrong. Can multiply sequence by none in the type is. Fuel type the value constant. Hold on. Well, this is how I made a plot in the first place. Value counts. Values. Yes. Value counts dot index. Yes. Petrol, diesel. What's wrong with this? Fuel type. Tell me this is the wrong thing. I don't think it makes a difference. Value constant values, value constant index. Can multiply sequence by non-int. Don't. Hold on. This is exactly how I got my flaws in the first place. Give me a second. There's something wrong with this. Explode function signature cosine of theta and theta counterclockwise. Yes. Non-int type float. Where do I have a float? Huh? I think there's anything wrong with this. Okay, I have understood that somehow. Sorry. Hold on a second. I think this is exactly what I did to get this plot out in the first place. What's your luck? Value counts the index the values. Yes. Huh. How is this not right? Hold on a second. This is exactly how I made this plot in the first place. There's no reason I could run it here and not there. Yes. Values. Values. Counts out values, labels. Index. Yes. Huh. Why is it not allowing me to give it by index? Don't tell me I somehow need to. Okay, I think it's a weird bug that I don't know why it even happened. Previously, I don't think I even need to do this at all to convert it into a list. But somehow, there's a weird bug happening with this value counts function. But anyway, you'll need a numeric array that sums, and you will need labels to actually do this. Huh. Why am I getting different results at two different times of execution? Anyway. That was supposed to be the answer, but if it works on your computer, then it's probably a Python version issue. I didn't have to convert this thing into a list before, but I guess somehow I need it now for reasons beyond my comprehension. I think it's a weird version issue. And, well, unfortunately, this type of error happens a lot when you're working with Matplotlib. Sometimes it's previously it was working with one of the data and one of the version, you update it, and unfortunately it stopped working. So feel free to give it a try. I think this one without conversion into a list was working before I rerun this notebook, but somehow it stopped working. Anyway, so couple of takeaway message for this pie chart exercise. For a pie chart, you're only supposed to visualize something that's, well, let's say less than 10 items in a list.
if you have more than 10 things, you probably want to merge a lot of those things into others. You don't really want to have like 100 of different items lines up in your pie charts. It's not a good visualization thing to do. Second is that for pie charts, you need to make sure your like label and your values are aligned in the right order. Otherwise, I could totally get something that's not really logical. For example, if I reverse everything, then my entire pie chart still looks nice, but it's not the right thing to visualize. Okay, so that's a little bit of Matplotlib. There's a lot more you could do with that. You can even do an animation of that if you want. You could be a like Matplotlib artist, visual artist, even though it's a very painful process to do. But you could try to create like your own painting in Matplotlib as a Matplotlib artist. I mean, there are some people that do painting in Excel and do painting in Desmos calculator, so you could totally do it in Matplotlib. I think there is actually probably a competition for that, but feel free to go into that. So here's another graphing package we're going to introduce. It's called Seaborn. So Seaborn is a not very common package, yes, and it offers most of the plots that's available in Matplotlib in a slightly different way. It's kind of a personal preference to use which one. I mean, for most of the plots here you could find, you could like in Matplotlib, you could probably find them in Seaborn as well. And most commonly speaking, Seaborn provide a little bit more statistical plots like a heat map, correlations, and confidence interval. So what are they? So a heat map is basically a type of map that's trying to show the correlation between any of the two columns you have. So let's imagine, okay, I have my hypothesis that the price and mileage are strongly correlated. Can I test this relationship? Yes. And one thing I could do is to run like the correlation with two arrays. I don't think this is the right syntax to do it. I think you need to hold on. I think I do have it somewhere. Anyway, df.correlation will do the autocorrelation for every single column. But you could also specify the correlation with, let's say, I think this one, yeah, I think this one is blank. You can see, okay, the correlation is negative 0.63, which means that there is some correlation, but not super strong. I could also switch that with, let's say, manufacture year of manufacture. Okay, I see a positive correlation of 0.7. That means the correlation is a little bit stronger. So for those of you who may not, I think I should have included something, but let's see. So when you're calling df.correlation, it's going to run a correlation for every single numeric columns in the data set. I'm specifying numeric only equals to true. I think if you don't do it, you will get a bug. Yes, because 4 cannot, how am I supposed to compare 4, how similar 4 is to, let's say, how correlated is 4 to the price? Well, technically you could, but you need to do some feature engineering. You will need to convert all of your categorical data into numeric data type. The easiest way to do it is to say, okay, Ford is 1, Porsche is 2, so on and so forth, and you can run that type of analysis. I think we introduced this method before, but for now, let's just make it easier. We're only comparing the numeric type. So it's only the price, the mileage, the year of manufacturing, and the engine size. And for all of this, if you see something, well, Matplotlib, this is Seaborn, will automatically encode how strong are the correlation. If there's no correlation at all, then it's 0. If it's a strong positive correlation, then it will be 0.7. If it's, and you will see it's more red, well, you can specify which type of color you want. I think the CMAP is cool warm. I think you could specify other type. I think if I don't specify that, you'll get a different color. Yes, now you got a different color. I don't really memorize the entire like CMAP you have. You can customize yourself, and I think there's like a dozen different built-in ones. But basically, blue one indicates a negative correlation. Let's see, mileage and price. Yes, my hypothesis is kind of correct. There's a medium level of negative correlation, which means that the higher the price, the lower the mileage, and vice versa. And this correlation between, like here in each of the grid is showing, okay, year of manufacture and year of manufacture. So the correlation is always 1. Like you're trying to see the correlation of A and A, your grade and your grade. Well, there has to be a perfect correlation because that's the same data. So here we got the heat map. It's a great way to show you, okay, oh, it seems like this block has a strong either negative or positive correlation here, disregarding the diagonal. Diagonal is just self-correlation, it's always going to be 1. For exactly why is that going to be 1, you can Google like Pearson correlation, and like, yeah, you'll see a little bit of reasoning about why is that the case. It's basically a statistical concept we're not introducing in full today. Okay, another type of common plot you could do is a pair plot, which is going to basically do you can specify the type of pair plots you'd have. Here I'm doing a pair scatter plot, which means that it's going to do a scatter plot like the one I'm doing here. Like this one, pair by pair. It's going to automatically do all the pair plots for you. So here, mileage to price is exactly what you get originally. And the problem is, you can plot it, but you can see a lot of nonsense plots. If you see plots like this, then what does it mean? It probably means that there's no correlation at all, or you're doing something wrong. And for these couple ones, you can also change the type of pair plots you see. For example, like I think it's obvious like these 3 is just transpose of each other, and this one is just rotating the axis by 90 degrees. This one is you rotate this one by 90 degrees, you get this one. You rotate this one by 90 degrees, you get this one, and so on and so forth. So I don't think it's not as informative. So I'm only including the ones that's unique here in the newer version of the plot. And here you can also see that I'm changing the type of plot for the diagonal one because, well, there's no point of plotting self-scatter plot. You're only getting a perfect result. So what I'm doing instead is plotting a histogram to see the distribution of data. And it seems like for mileage, our data is not normally distributed. There are a lot of outliers. And I would say it's right skewed significantly. And maybe I would say you could also think about its kurtosis and like second moment, the third moment, etc., if you know the statistics to use. And for this one, I would say it's a little bit more normal, but not perfectly normal because there's like a plateaued distribution here. If you know the right statistical term, we can say it's less kurtotic compared to normal distribution. I don't know why these terms are so difficult to pronounce. And here, yeah, and so on and so forth. So have fun with plotting. A lot of the time you'll need to adjust this. I would say this is a good way to quickly give you some overview of how the correlations across the data sets might look like. But in order to say the pattern you see, I mean, put it this way, what do I need to put in, when do I ever need to do a plot? When I want to show something to someone that doesn't really want to look at a data frame, right? So how can I use this, when I'm showing this plot, chances are, okay, I'm trying to convince my boss or my friend, okay, there's a strong correlation or a negative correlation between price and mileage. Is this a good plot? Well, it kind of says the story, but it's kind of doesn't look nice. How can we make sure it looks nice? Well, you need to go back into adjusting the limit, like, where is it? Like this one we're doing here, adjusting the limit, adjusting the range, adjusting the number of points on your plot, and so on and so forth to make your plot more convincing. You can also adjust the color, make a line of best fit, and show something more. The point is, there's no such thing as the perfect way to do data visualization. A lot of the packages will say, okay, we can do automatic data visualization with AI and so on and so forth. But this is exactly what do we get out of AI, unfortunately. This is exactly what you get when you tell ChatGPT to say, oh, please generate a pair plot. Does it look like a good pair plot? Probably no, because of various reasons. So is this pair plot good enough? I would say no. Where else could we work with? I could try to make it slightly better by this. And another thing is, okay, I might want to change this like engine size into like categorical variable instead of like change this type. Engine size seems to be a categorical variable, not a continuous variable. This is exactly what happened when you were trying to plot a categorical variable as a continuous variable. It seems like engine size is not, you're not going to see like 2.57 engine size. So what is a better plot here? I would say a bar plot is a lot better than like this weird looking scatter plot. Can I change like everything into a like bar plot? The answer is yes. I think there's an argument called, where is it? Palette, no, y versus back, kind equals to bar. I think that's something better. Okay, I can't even get it because some weird reason. What do I miss? KDE, DF. Okay, apparently I can't do it this way. Huh. Oh, that's right. Because if I change everything into bar plot, that means I think the bug I got is because I'm trying to plot this as a bar plot. If I change the kind into bar plot, this is exactly what do I get. It's not what's ideal. So let's try, let's see, engine size, and let's see, DF price, let's see. We should get slightly more meaningful plot from here if everything goes right. Of course, there's always a chance that this is not good. Wait, did I change my, oh, I think, did I set index? Okay, apparently I set the index wrong, so it's not going to be a good thing. Because I set the price to be my index, so there's no column as price anymore. Yes. Anyway, okay, let's use mileage. It's probably going to take a while to plot. If you're plotting a large data frame, you might actually crash your computer. Plotting is GPU intensive. I think Colab should be fine to handle that. Let's see how long does it take to plot 50,000 data point. Probably not the best idea to plot it this way. Okay, I'm only plotting the first 50 ones. Not a good idea to plot 50,000 ones. Okay, this is what you got. A little bit more informative somehow. So feel free to play around with it. Yeah. Seems like we still have a correlation between the price and the engine size, but not a strong one. Let's see if we can, what happened when we plot it into 500. Something like this. Okay, there's a weird caveat between in this specific engine size for a reason that I don't understand. Maybe you guys could figure out what's happening with that. So have fun with data visualization. This is some of the way that data analysts and data scientists do when they first got a data set. Plot out a couple different plots and see, okay, maybe something is right about this data set, something is wrong about this data set. What can I say about this? What can I generate a report? How can I improve my current algorithm or improve whatever? And yeah, if your plot is collapsing, maybe you're plotting too many points, you can try to restrict the points you have. This is what I'm doing here. And also select the right type of plot to make sure your plot is making sense is important. Otherwise, you'll get something like this. This is not the plot type of plot you should be using for a categorical variable in scatter plots. Again, if your plot looks messy, then something is probably wrong. For this specific data set, I think plotting a pair plot is not a good idea. Pair plot is usually a good idea when you have less data points, but not like a super large data sets like 50,000 ones. So I think that hopefully this gives you a basic sense about how plotting would work. Also make sure if you see a lot of the like type error, that's probably because you are not converting the data into numeric data types. That happens a lot when you're reading the data sets, even though sometimes 1.0 may still be treated as a string somehow. So always check your data type before running the plots. Otherwise, you'll also get something like errors like this and so on and so forth. And hopefully this is a helpful overview for different plots you might need for this week's assignment. And yeah, I think that's all I have for this week. Feel free to let me know if you have any questions and have fun. Stop recording.